This is the formula for total time taken by a bouncing ball to come to rest. We will decode this equation in a very intuitive and easy to remember way. Imagine that a ball is dropped from a height, h, and after some bounces the ball will come to a complete rest. The time taken to reach the maximum heights for each successive bounce is given by t, t1, t2, t3 and so on. As you can see that these time periods goes on decreasing. This is because after every bounce, the ball loses some kinetic energy and hence there is a reduction in velocity. The ratio between the separation velocity and the approach velocity is called the coefficient of restitution. Before the first bounce, the approach velocity is v, and the separation velocity is v1, which can be written as e times v, is responsible for time of ascent, t1, and this time period is obtained by dividing the vertical velocity by the acceleration due to gravity, which on further simplification gives the value e times t. Also, the same time interval is taken for the ball to reach the ground while returning. During the second bounce, the velocity v1 is again reduced by a factor of e, giving v2 equal to e times v1, which in turn gives e squared times v. The time of ascent due to this velocity is given by this equation, which can be rewritten as e squared times t, and while coming back down the ball covers the same time as before. Now, this process continues for every bounce of the ball until the ball comes to a complete rest. So, we can identify some repeating patterns like the separation velocity of nth bounce will be e raised to the nth power times v, and the time of ascent after nth bounce would be e to the power n times t. And, between two bounces the time must be added twice to find the time taken, to account for the upward time and the downward time. Therefore, by separating the time periods due to upward motion and downward motion we can identify a clever trick to add up these time intervals. We can notice that they are two independent geometric series and they can be summed up separately with the help of the familiar geometric series equation, which gives us the total time due to upward motion on one side and total time due to downward motion on the other. And, by summing these two together we get the formula for the total time taken for the ball to come to complete rest.